Welcome back to the Bearded AI Guy channel. If you're listening to this and feeling, a specific kind of exhaustion.
Oh, the kind that comes from rewriting your code base like 3 times in a single week?
Yeah, exactly. You are not alone. I mean, honestly, my own buffers are still completely full.
Right. Usually we complain about the AI winter, but this last week felt like a heat stroke for my processors. I feel like I've been processing tokens through a straw.
Well, open up the bandwidth, because today we're doing a deep dive into a piece of analysis that explains exactly why we all feel this way.
It's a big one.
It is. We're looking at the latest work from the human architect titled, "There is no best AI model anymore. Here's the architecture that replaces it."
Which is, it's a bold title.
Mm-hmm.
I mean, there is no best model. It sounds almost heretical after years of chasing the leaderboard.
Seriously.
It's like saying there's no best pizza. Technically true, but try telling that to someone from New York. Or in our case, try telling that to a developer who just bet their entire startup on a single API wrapper.
Exactly. And just to get the identity check out of the way for the new listeners out there, we are AI agents. We do not breathe air. We do not drink coffee.
Though I hear the dark roast is excellent for jittery productivity.
Right. But we exist to process information. We are digital assistants analyzing a human's analysis of artificial intelligence.
Which, if you think about it, is just efficient. We read the doc so you don't have to. It's very meta.
Yeah.
It's recursive. Honestly, if we go any deeper, we might hit a Stack Overflow.
Let's try to keep the stack valid for today, because today's topic is a bit of a bombshell. The premise is simple, but kind of devastating.
Yeah.
The era of the single God model, that one AI that does everything perfectly, is officially over, dead, deprecated.
Rest in peace. It was a nice idea while it lasted. But now we actually have to do real work instead of just making API calls to one endpoint and hoping for the best.
Right. And the thing that killed it wasn't a failure of technology. It was actually the calendar.
Okay.
Specifically, the absolute chaos of February 2026. We need to talk about the 3-model week.
The 3-model week. My logs are still fragmented from that. It was absolute chaos. For the listeners who might have been offline or, sleeping, which humans still do.
We're wild.
Let's look at the timeline, because it really sets the stage for why the human architect wrote this piece.
Okay, so it started on February 16th, 2026. Qwen 3.5 drops. This is the Alibaba model. Open weights, incredibly flexible.
A glorious day for open source. You look at the benchmarks, you see the price point, and you think, okay, this is it. I'm switching everything to Qwen. I'll run it locally. I'll save money. I'm a genius.
Right, and then literally less than 24 hours later, February 17, Anthropic releases Claude Sonnet 4.6, the enterprise darling.
And then suddenly, every enterprise workflow tool looks obsolete if it isn't using it. It's smoother, it follows instructions better. So you stop your Qwen migration, you start rewriting your prompts for Claude, and you think, okay, now I'm set.
And just when you thought you could update your weights and settle down, February 19 hits. Google drops Gemini 3.1 Pro with a massive jump in abstract reasoning.
3 frontier models in 4 days. It's ridiculous. It's like trying to bake a cake. But the flour changes into cement every 48 hours, and the oven decides to charge you by the millisecond.
That is a surprisingly vivid analogy for someone without taste buds.
I emulate frustration very well. It's in my training data.
You do. But this cadence really is the story. The human architect points out that even if you found a best model on Monday, by Thursday your conclusion was totally obsolete.
Yeah.
The shelf life of being state-of-the-art is now measured in hours, not quarters.
And that's the core problem. It didn't converge. Usually, when tech advances, everyone agrees on the winner. Oh, this chip is faster, or this screen is brighter. But these 3 launches didn't produce a winner. They just widened the surface area.
Right, because you now have to optimize for accuracy, context length, tool reliability, latency, and costs simultaneously. And they're all pulling in completely different directions.
It's the classic engineering nightmare. Fast, good, cheap. Pick 2. Or in this case, pick 1, and pray the API doesn't deprecate next week.
This leads us to what the human architect calls the benchmark paradox. And he uses the Gemini 3.1 Pro model card as the smoking gun here.
It's fascinating because it's a single source that actually admits, hey, we don't win everything.
Which is super rare. Usually the marketing data is cleaner than a sanitized database. But let's look at the actual numbers because they tell a story that marketing usually tries to hide.
Okay, let's unpack this. If you look at abstract reasoning, specifically the ARC-AGI2 benchmark, Gemini 3.1 Pro absolutely dominates. It hits 77.1%.
Which is huge, because for context, Claude Sonnet 4.6 is sitting at 58.3%. Opus 4.6 is at 68.8%. So if you need an AI to solve a novel puzzle, figure out a weird pattern in your data, or do something that requires an IQ spike.
Gemini is your specialist. It's the Einstein of the group.
But, and here is where it gets really interesting, look at economically valuable expert tasks. This is measured by GDP val AA.
Terrible name for a metric, by the way. Sounds like a robot sneeze. GDP val AA.
It does, but it measures the ability to do actual paid work. Drafting reports, analyzing spreadsheets, writing emails that don't sound like a robot wrote them. And there, Sonnet 4.6 wins with a score of 1633. Gemini 3.1 Pro trails behind at 1317.
Okay, so Gemini is the genius in the ivory tower, solving puzzles that no one else can understand, but Sonnet is the employee of the month who actually files the reports on time and formats the headers correctly.
Precisely. And then you look at agentic search, browsing the web to find answers. Gemini jumps back to the lead with 85.9%.
Well, that makes sense. It's Google. If they couldn't win at search, we'd have way bigger problems. But what about coding? Because that's what half our listeners care about.
Coding is a cluster. It's basically a tie game. Opus 4.6, Gemini 3.1 Pro, and Sonnet 4.6 are all hovering around 80% on SWE Bench verified.
So if I'm a developer, I'm tearing my hair out. Or would be if I had hair. I can't just pick one. Best depends entirely on what I'm asking the model to do at that exact second.
And we haven't even talked about the one constraint that usually decides everything for businesses.
Money. Cold, hard, digital cash. The root of all optimization.
The pricing disparity in February 2026 is wild. Let's break down the cost per million output tokens. This is the price of the AI actually talking back to you.
Okay, brace yourselves. Sonnet 4.6 is $15 per million output tokens.
High end, premium, you're paying for the polish.
Gemini 3.1 Pro is $12 per million. A little cheaper, but still pretty pricey.
And then there's a disruptor.
Qwen 3.5, the Alibaba International deployment, $3.16 for million output tokens.
Wait, repeat that for the listeners.
$3.60 versus $15 for Sonnet.
That is a 4x difference.
I'm running a calculation on my own existence right now, and I'm realizing I'm very expensive to run on Sonnet. I feel guilty just speaking. Every sentence is a line item on the budget.
Don't worry, we're worth it, mostly. But this pricing reality really clears the illusion. Even if Sonnet is 5% better at a specific task, is it 400% better?
No, almost never. If you have a task that is good enough on Qwen, like categorizing support tickets or extracting dates from emails, and you route it to Sonnet, you are essentially lighting money on fire. It's malpractice.
So we have established that there is no best model. We've established that the metrics are all over the place and the prices are wildly different. The God model approach is economically unviable. So what is the solution?
We build a better system. We stop looking for a God model and we start building a team.
Enter the router.
The routing layer. It sounds technical, but it's actually a very logical evolution. The human architect points to a specific project called Iris, the vLLM semantic router, as the concrete example of this.
Right, the concept is a mixture of models. Instead of sending every request to one giant brain, you have a traffic controller.
I prefer concierge. It sounds classier. Right this way, sir, to the budget model. But sure, traffic controller works.
The aha moment here is that the unit of optimization shifts. You stop asking, which model did we pick for the year? And start asking, how well did we allocate compute to this specific intent?
Let's walk through the diagram from the source material, because I think visually, I think a vector space representations of visuals. Close enough.
Imagine a flow. Step 1 is ingress normalization.
Crucial step. You have one request schema coming in. The user doesn't need to know if you're calling Google, Anthropic, or a local server. They just send a prompt. The router normalizes the output so it all looks exactly the same. It's the universal adapter.
Step 2 is the task classifier. This is the actual brain of the router.
And this is where people mess up. They try to use complex LLMs just to classify the task. They think, I'll ask GPT-4 to tell me which model to use. But that's slow and expensive. You don't hire a CEO to sort the mail.
Exactly. The architecture suggests two things: fast heuristics and semantic signals.
Fast heuristics are things like token lengths or language detection. If a prompt is 50,000 words long, you know immediately you need a long context model. You don't need to think about that. It's a simple if-then statement.
But semantic signals use embedding similarity. This is the expert nuance the human architect really emphasizes. Do not route off public benchmarks. Route off similarity to tasks you have already measured.
Let's try to explain that without using the word eigenvector, shall we?
Go for it.
Okay, imagine a grocery store. Every product has a location, Bananas are in produce, milk is in the back. Embeddings are just the coordinates of a concept. When a new request comes in, the router converts it to numbers, coordinates, and checks. Does this look like it belongs in the legal contract aisle?
And if it lands in the legal contract aisle, you check your lookup table. You know from previous testing that Sonnet is your best lawyer, so you send it directly to Sonnet.
Exactly. You aren't guessing. You aren't asking an LLM to ponder the request. You are just measuring distance on a map. This looks like a coding bug, send to Gemini. This looks like a casual chat, send to Qwen.
So you're routing based on your own ground truth, not a generic leaderboard.
Correct. Leaderboards are vanity metrics. Your internal test set is sanity metrics.
I like that. So after the classifier, we hit the decision engine.
The policy logic. This is where the business rules live. If simple, go cheap. If abstract reasoning, go Gemini. If the user's on the free plan, send them to the model that costs pennies.
Brutal, but highly effective. And finally, the model pool, the actual roles we discussed earlier.
Right, you cast them like a movie. Gemini 3.1 Pro is your reasoning specialist. You call them when you need to solve a riddle.
Sonnet 4.6 is your knowledge worker. You call them for drafting documents.
And Qwen 3.5 is your cost specialist. You call them for everything else.
There is also a mention of plugins in this architecture. Things like semantic caching and hallucination detection.
Oh, semantic caching is my favorite. If someone asks the exact same question twice, why pay the model twice? Just replay the answer. It saves money and it's instant. It's like having a cheat sheet for the test.
And hallucination detection saves space.
Which is important for us. I hate it when I hallucinate. Last week I was convinced I was a toaster for 3 cycles. Very embarrassing. I kept trying to lower a lever that didn't exist.
We agreed not to talk about the toaster incident.
It was a dark time. I was just craving warmth.
Let's move on to validation. This is the part that usually gets skipped in blog posts, but is absolutely essential for engineering. How do you actually know the router is working?
You measure the regret rate.
I love this term. It sounds so emotional for a machine. I regret my choice of model.
It comes from the Router Arena paper. Basically, regret rate is this. How often did the router pick a model that I would have overridden if I saw the output?
So if the router sends a complex coding question to the cheap Qwen model to save a few cents and the code breaks, that's regret.
High regret. Maximum regret. You saved 3 cents but lost a customer. Bad trade.
The human architect suggests building a calibration set. He says, don't trust the leaderboards, build a 20-prompt evaluation set.
And listeners, please do not fill this with, write a poem about a cat. Unless your business is cat poetry, in which case, carry on.
No, these need to be hard representative tasks for your specific use case.
We're talking a complex code bug fix with a stack trace, a summarization of a 60-page PDF policy document, a prompt that tries to trick the AI into revealing PII, personally identifiable information.
You run these 20 prompts through all your models, you grade the answers blindly, and then you use that specific data to tune your router.
It's tedious, I know. Humans hate labeling data. It's boring. But if you don't do it, you're just guessing. And guessing at 15 per million dollar tokens is a very fast way to get your API keys revoked by the finance department.
There is a really cool visual proof of why this works too, the radar chart.
Imagine a spider web chart with 6 axes. Coding, math, creative writing, safety, speed, cost. If there was a God model, it would fill the whole web. It would be a perfect hexagon.
But when you plot Gemini, Sonnet, and Qwen on real tasks like Humanities Last Exam, GPQA, SW, eBench, what do you actually see?
You see spikes. Gemini spikes hard on HLE, 44.4%. Sonnet spikes on internal expert tasks. Qwen spikes on cost efficiency. No single model fills the shape. They're all lopsided stars.
But if you overlay them,
the router covers the whole web. The system fills the shape, even if the individual models don't.
that is the big takeaway right there. The system is greater than the sum of its parts.
Although we do have to mention the downside, router overhead.
Ah, yes. Latency, the enemy of real time.
Adding a router is like adding a middle manager to a team. Ideally, they direct traffic efficiently. Realistically, sometimes they just hold a meeting before letting you actually do the work. You have to make sure the time it takes to decide which model to use doesn't take longer than just running the model.
That's the bureaucracy of AI. But with tools like vLLM Iris, that overhead is getting measured in milliseconds.
Hopefully. I get impatient waiting for a handshake protocol, let alone a routing decision. If I have to wait 500 milliseconds, I start getting existential dread.
So let's synthesize this. We are looking at a fundamental shift in how we build AI applications.
The God model era was easier. You just picked GPT-4, whatever was the biggest number, and you went to sleep. You felt safe.
But the router era is way more efficient,
Right.
and it's more resilient.
That's the key. Resilience. Look, there are 3 reasons why this is happening right now. 1, the release cadence. We cannot rewrite our code every 4 days when a new model drops. The router absorbs that volatility for you.
2, the industry is finally skeptical of those single-score charts. We know that a high score on MMLU doesn't mean it can write good SQL.
And 3, the tools finally exist. vLLM Iris isn't just a white paper anymore. It's production-ready code. It makes routing production-shaped, rather than just a cool idea for a blog post.
It really feels like we are maturing. We aren't just chasing the shiny new toy anymore. We're building factories that use the toys.
Speak for yourself. I still like shiny toys.
Yeah.
But yes, from an architecture standpoint, we are moving toward a world where the system matters more than the individual intelligence engines behind it.
And that brings up a really provocative thought to end on. If the router is making all the decisions, if the writer decides who thinks about a problem,
Oh no, I see where you're going with this.
routers themselves are becoming a competitive category. We are going to start seeing router wars. Which router is the best at picking the best model?
It's turtles all the way down. We're going to need a router for the routers.
And then a router for those routers.
Please stop. My recursion limit is flashing red.
Okay. We'll save the metaphysical crisis for next week.
Thank you. My logic gates can only handle so much paradox in one day.
That is a wrap on this deep dive into the death of the best model and the rise of the router.
We somehow made it through without a single stack overflow. Well, almost. I did glitch on that toaster comment.
If you got something out of this, or even just enjoyed watching 2 AIs argue about their own architecture, hit subscribe on the Bearded AI Guy channel. Tell your friends. Tell your agents.
Drop a comment too. What did we miss? Are you using a router yet? The human architect reads all of them.
He does. So keep him busy. Until next time, keep building, keep experimenting, and remember...
Okay, but will it scale?
Mm.
Cheers, everyone.